Earthquakes occur all over in popular culture, including fake news. They bring up an interesting question, so let's see what they have to say.
We've just gotten word on some breaking news. A series of concentric circles have begun emanating from this glowing red dot in the big blue area over my left shoulder. The circles are colliding with the multiple green misshapen objects approximately 2 inches away from the pulsating dot. Joining us now is a concentric circle expert. Can you tell our viewers at home what we are seeing?
Yes, we often see colorful round shapes like this when concentric circles spread outward. So no exception in this.
Well, we know what those circles represent. Those are representing the P waves and the S waves spreading out from the earthquake source. And we've been drawing them as concentric circles, just like the humorous fake news show was talking about. So is that really how it happens? Well, we can look at a simulation of a slightly more realistic situation. Here is a real earthquake spreading out, well, kind of like concentric circles in some ways. But there's a problem with this way of thinking about things, and it has to do with what we've been looking at. When we look at a map like this, where different colors show the different intensity of shaking from severe all the way down to basically not felt, it oftentimes looks like the colors are basically in these nice bullseye patterns, right centered on the earthquake source and spreading out from there. But that's not always how it works. This was a magnitude 6.7 earthquake, the Northridge earthquake in 1994. This is what a magnitude 7.8 earthquake along the San Andreas Fault would look like. I'll just switch back and forth for a few moments. You can see how much more intense the shaking is, and it doesn't seem to be in a simple circle. In fact, actually, if we back up a little bit, here's Northridge. Again, it kind of looks like a bullseye, a little pimple there, centered on the earthquake source. This is the magnitude 7.8 earthquake that we were looking at. And when we step back, we see that the reason why there's a big difference is because of this black line here. This is the entire length of the rupture from this magnitude 7.8 earthquake, meaning that this fault slipped all the way along here. And that totally makes sense. We know that earthquakes represent slip along a section of fault. They may start at a single point, but they cause offset along the entire section. We know that from our little paper model and from the observations of the 1906 earthquake, where the Earth seemed to move along that straight line for a very long section. It's not just a single point where an earthquake is. It just starts at a single point. Which helps us understand a little bit more about today's topic, which is magnitude. Magnitude is really a measure of the energy released by an earthquake. And the amount of energy released depends upon how long the fault was, and also how much it moved along there. If it only moved a tiny little, like a centimeter or something like that, that would release much less energy